Today's Daily Dose of Math is about rounding. Now this is mostly a review for my students, but it's an important review. And I find that students do know an awful lot of the details, but they have a tendency to forget the terminology. So maybe it's mostly a review of terminology. Starting with the chalkboard here, we have a large number, 345.678, and illustrated what each position in the number is called. So the 3, it's 300, the 3 is in the hundreds position, 4 is in the tens position, 5 is in the ones position, also called the unit position, 6 is the tenth, 7 is the hundredth, and 8 is the thousandth. Watch out for that TH at the end of these words because it makes a big difference. If a student wants to rely on the sort of symmetrical nature of this to help them understand, it's not really very useful because normally we would expect to see symmetry with the decimal being the point in the middle. That would represent the mirror. And we don't have tenth just to the right of the decimal and 10 just to the left. The 10 is over here. So in terms of these terms, relying on symmetry is not a good idea. Knowing the names for these positions allows us to round numbers to the nearest this or the nearest that. But we also have to apply this rule down here. If the digit after the position we're rounding to is 0, 1, 2, 3, or 4, we round down. And the number in the position that we're rounding to doesn't change. If the digit after the number we're rounding to, after the position we're rounding to, is 5, 6, 7, 8, or 9, we round up. And the digit in the position we're rounding to does change. It goes up by 1. Now let's look at some examples. 562 to the nearest hundred. The 5 is in the hundreds position, and the number after it is a 6. So I'm going to round up because of this rule, and therefore 562 to the nearest hundred is 600. Notice that 5 gets bumped up to a 6. 562 to the 10 is where the 6 is. That's the position, the tens position. The number after it is a 2. So I round down. I have 560 when I round 562 to the 10. The 2 is gone, we replace it with a 0, and the 6 stays a 6, because the number after it was from 0, 1 to 4. 3.48 to the unit is the 3. The number after it is a 4, I round down. 3.48 to the unit is 3. The 3 doesn't change. 3.48 to the 10th is where the 4 is, but the number after it is an 8, so I round up, and my answer is 3.5. 0.1382 to the hundredth. The 3 is in the hundredth position, the number after it is an 8, so I round up, and I have 0.14. And 0.1382 to the thousandth. The thousandth is the 8, and the number after it is a 2, so I round down, and my answer is 0.138. Now, if you'll be patient, I'm going to make a few more examples on this whiteboard, and then we'll go into some examples that include some things that are a little bit more complicated. Okay, so we have some more examples ready. Here we have 0.6 repeating, and we want it to the nearest hundredth. The hundredth isn't even showing in the way this number is written, but we know that 0.6 repeating means 0.66666, and it keeps going on. Now we can see the hundredth is here. So we will round to 0.67. We're using the same rules. The number after that 6 that's in the 100th position is a 6, so we round up, 0.67. 0.3 repeating to the 1000th, we know that means 0.333333, and it keeps going. Now we can see the 1000th is a 3, and the number after it is a 3, so we round down. We get 0.333. Here's a weird one. 6.097 to the 100th. The 100th is the 9. And the number after it is a 7. So that means I have to round up. That 9 has to be increased by 1 to a 10. So if I show my decimal, that 9 is the second number after it, and it's now a 10. All I can show is the 0. The 1 from the 10 has to go into this position, and I have to show my 6. So 6.097 to the 100th is 6.10. It's strange, but this is how it works, and you will get used to it. Another similar example, 6.997 to the 100th. The 100th is this 9, the number after it is a 7, so that 9 has to go up to a 10, which means I show a 0 in that position. And the 1 goes into the next level, the next spot to the left, but the next spot to the left this time is another 9. I'm adding that 1 to a 9, so I'm getting a 10 again, which means I put a 0 here, and the number to the left of that has to go up. So weirdly, 6.997 to the 100th is 7.00. And you have these numbers that end with 0. The zeros have to be shown, because they ask to the 100th, you have to show 2 numbers to the right of the decimal in each case. I have to put zeros there. Now we have a situation where we don't follow the normal rules of rounding. 44 meters squared of wall has to be painted. 1 can of paint covers 10 meters squared. How many cans do I need? It's a simple calculation. I take the area of the wall and I divide it by the area that a can of paint can cover, 44 divided by 10, and I get 4.4. But 4.4 would round down to 4 cans, and that's not going to be the correct answer because this situation requires us to paint the whole wall. We won't have enough paint if we only buy 4 cans of paint. So we buy 5 cans of paint. That is today's Daily Dose of Math. Please like, subscribe, and share.